Every now and again I like to come here. I've been here several times, and the reason why I like being here is because it's crazy technology, modern things happen. It just fascinates me. This is Dastek Unipower's factory. I know it looks like a laboratory, but this is actually a factory. It's almost hermetically sealed, where they design the Unichip. Now, four-wheel drive vehicles to me are very special. You know that. But it's because one vehicle so often is asked to do so many things, and it's expected to do them extremely well. Let's take a Pajero. It's expected to take the kids to school comfortably and safely. And on the weekends, it'll be asked to drive up a mountain on a weekend off-road trail with a family and kit in the back. And on holiday, a caravan or trailer will be hitched to the back, and it'll be asked to do 120 kilometers for 2 whole days and not use too much fuel. I mean, if you think about it, asking one vehicle to do all of those things well, that's a tough ask. Now, some vehicles do most of those things quite well, and some of them not so well, and others really, really well. Well, Dastek Unichip, this is a device that actually helps those vehicles do everything really, really well.
And here it is. It's really just a very clever piece of electronic circuitry, built by robots, then checked by robots, and then finally checked by humans. And this is the human that developed it. Passionate engineer and very clever person, Peter de Veert.
The first thing I want to do is I'm going to drive the vehicle.
Who is now going to show us how clever he is. Well, it is.
We use a dynamometer. Our dynamometers, you can simulate cruising conditions as well as full throttle conditions. So we don't use a dynamometer only to make maximum power or to race. We use them to actually optimize vehicles under different driving conditions. So basically we can drive the vehicle on the dyno under many different conditions, different RPM points, different load conditions, full throttle, light throttle, and we can tune the vehicle differently under each point. So I can simulate driving on the freeway at a steady speed with light throttle, and I can again tune the vehicle at different throttle positions, different RPM to different mixtures. Now if you look at the moment, let's go to say 3000 RPM or maybe 3.5 even as a typical cruising RPM. We will see on the air-fuel ratio meter at the moment it is showing 12.4 to 1. So that means it is using 12.4 kilograms of air for every 1 kilogram of fuel. Now for economy, that is way too rich. So if I go and with a Unichip, I turn my fueling button to the left, you see the air-fuel ratio is actually changing. And that's going to about 13.7, 13.8, and maybe I want it down about 14.6, 14.7 for cruising. That will be good for fuel consumption. Now, we've lost a little bit of power for cruising, but while we're cruising, we are not concerned about power. We want, our most important aspect is to have optimum fuel consumption. If I go full throttle, I can now tune it differently. So there's 14.7 at full throttle, which is a little bit too lean. You see, as I change the mixtures, you can see the power actually pick up in order to get to the optimum point. So it's not only for power, you can also, it is for economy and power, you can get the best of both worlds depending on your actual driving style. So you can find the absolute optimum point, ignition timing point at different throttle, different RPM for each specific individual vehicle. So because no two vehicles are identical, that's the reason we will tune individual vehicles for that engine's optimum performance under different conditions.
Now with a diesel vehicle, things are a little different.
Now at any given RPM, I can switch it on. So I tell the dyno, load it at this particular RPM. And you see, the dyno is now keeping it, in this case, to just over 2000 RPM. And as I'm pushing my foot, throttle-wise, more, you will see the power actually increasing on the dynamometer. What we did on this particular vehicle, being a diesel vehicle, we have first of all a map which is a normal standard map to show that's the way it is without the Unichip in it. And then we have a day-to-day map which is driving like day to day, basically what it says. Then there's a serious power map. And on a diesel, you would use that only for a short distance if you need to get up a hill or you want to do something quite seriously for a short period of time. On a diesel, if you run prolonged with a lot of extra diesel, the temperature can become a problem. And that's why the day-to-day map is safe for every day-to-day driving. The serious map, just if you want to have a serious short sprint. And then you see there's here a towing map, which the towing map actually makes less power than the day-to-day map. It's more than the standard vehicle, but less than the day-to-day, because if I'm towing it for a prolonged period, I don't want the engine to overheat, I don't want to overfuel. So a towing map we make a little bit more conservative than a normal day-to-day map, where you're going to be driving and taking foot on off. So what really kills the diesel is continue foot flat through the Karoo with a trailer and a beach buggy and a caravan. So that's why we make that the towing a little bit more conservative than the other. And then lastly, there's a immobilizer map on here. If you don't want your vehicle to get lost, you can set it, and in that case it's not going to run. And the beauty about that part is there's no button to find. There's no hidden button the guy can push to override it or bypass a wire or something. It's physically done with the phone. So if you don't have the phone, you're not going to start the car again.
So it seems that the electronic engine management system in our vehicles can be improved by fitting of a programmable piggyback computer. And while these are available off the shelf, this demonstrates perhaps the value of having one's vehicle fitted and then personally dynotuned as well.